Hello, everyone. Thank you so much for joining us this afternoon for the year two update of the Pathways projects in the Center of Workforce Innovation for Electric Vehicles. We really appreciate all of our education and industry partners who've been engaged now for 2 years in this statewide initiative. Um, just the fact that we've been able to break down silos and partner together to improve and create new pathways and programs for traditional students, non-traditional students, adult learners, incumbent workers, apprentices, means a lot to the economy in our state. It ensures that New Jersey residents are able to get the education and training they need to have a family sustaining wage. And it means that we are aligning education to build an innovative workforce so that our businesses may thrive in the state. So thank you so much for your continued participation and support. That's an old picture of me. Let's flip through. Everyone knows who I am. Here's our agenda for today. We will get updates from the education partners engaged in the electric vehicle pathway projects for year two. We will have a question and answer segment. So please put all of your questions as they come to mind in the chat. We will get back to them, we promise. And then lastly, we will share with you some upcoming pathway events that are on the horizon. Next slide. Here are our education partners engaged in this Center of Workforce Innovation for Electric Vehicles. As you can see, there are high schools, there are colleges. We're very about the level of engagement and certainly very happy to share with you where we are so far. These pathway projects will end June 30, and we start year three of the Pathways Initiative July 1. So this is just a little snippet of what we will share with you after the fiscal year end. And also all of this information will be on our njpathways.org website. So the lead institution for the Center of Workforce Innovation for Electric Vehicles is Bergen Community College, and their representative is PJ Ricardo. PJ, I'm going to turn it over to you.
Great. Thank you, Catherine. Can everybody hear me? Okay, so Steph, if you can advance to the next slide. What we are going to do is we have on our team, we have 3 community colleges working, and the first 2 community colleges really are the bulk of the work that's going on, and they are curriculum development. First is Camden County Community College, and it's led by Andy Manalpen, who's also a high school VOTEC teacher at Camden County Technical Schools, and he's also an adjunct at the community college. So what's exciting about this college, this program, is its curriculum development designed to specifically for dual enrollment students and transfer of high school credits to college. And that works perfectly well with our second project, which is at Raritan Valley Community College, which is designed for curriculum development for the community college students in an automotive program there. So those 2 programs are working together so that what's learned in each, it can be shared amongst them. So I'm going to let Andy take over from there. Stephanie, if you can advance the slides.
Hello, everyone. Just to tell you a little bit about what we've done here at Camden County College and Camden County Technical School. We want to try to put together a 3-step process here where we're integration, and piloting of the new ASE standards for electric vehicle safety into a non-credit certificate program at the community college level. Basically, that started off with designing and working with the high school. The implementation of the automotive technology program at Camden County College was in partnership, through the few instructors that are both at the high school and at the college. Basically, we wanted to develop and design courses to incorporate the foundational knowledge and practical skills which are necessary in the industry right now for electric vehicle safety standards. And as we move into, I'm going to say, a new generation or a line of electric vehicles that are hitting the market in droves and gaining population, we wanted to build the course aligned with the industry standards, which ASE, the Automotive Services Excellence, has kind of taken charge in the last 30 some years. We're building the automotive industry with standards. High voltage vehicles can be very dangerous, so it's very important to build these standards and have a curriculum that helps individuals out there. The targeted audience we wanted to find is enhancing the expertise in handling hybrid and electric vehicles in line with industry standards. As we move into the next slide, which would be, what we wanted to put together in the courses, we want to initiate a concentrated effort into integrating, the safety standards in our curriculum. The National Automotive Technicians Education Foundation is where the high school is accredited through, and that is a part of the ASE group itself. So the main goal was to extend the pathway from the high school to the community college. So we wanted to go down into the high school curriculum and start the foundation of the electric vehicle safety and build a comprehensive curriculum developed in the 3 different steps of courses as we aligned it to the ASE 2 standards that were out there. The first course was the integration into the high school curriculum. We focused on establishing a baseline or a general purpose for the introduction to the student. The second course is aligned to the ASE Electrified Propulsion Vehicle Level 1. That's where, in that course, we took the standards and we wanted to have it more built into, deepen the learner's understanding for safety awareness when working with EVs and high voltage components. That course kind of is a neat aspect where it's not just for a technician, it's for anybody in a service lot, in a dealership, even a parking attendant, just anybody that works with a high voltage vehicle. And it doesn't have to be just for the technician, because there's many careers out there that are going to be built around working with the electric vehicles. And that leads us into the third course, which becomes a little bit more intense. And that intensity is in the repair process. So that would be for advanced students. That's for I would say it'd be more of a technical proficiency in working with EVs. And that's where we tried to put the whole thing together, was to bring it into a perspective that everybody could see. When I look at most of what we were doing here between the technical high school and the college, we go into, we'll move to slide 3. I met with some industry individuals back in July at the ASE summit. They usually have a yearly conference. And in the picture there are some colleagues that I worked with. I've known these guys for almost 30 years. Basically, the first guy, from your left to your right is Matthew Shepanek. He is the gentleman that I used to work with, I'm going to say, many years. I reached out to Matt. Matt works for ASE now. He's responsible for all the new standards and testing. So I wanted to pull from, and get their perspective. He also, the guy on the far in the red, that's Jim Doyle. He's from Audi of America. He's one of their service instructors out in Chicago. Jim and I go back a long way. We've done a lot of course development, a lot of subject matter expert, where you come in and you learn as much as you can, and then you put a course together. Jim Delaney was a Volkswagen specialist at Auburn Hills when I worked between New Jersey and Auburn Hills. And it was just neat. Just I went to the conference and these three guys were there. We started, bouncing some stuff off on how to put these courses together and what should be put into an EV course and what is standards, because there's an array of, I would say there's a lot of, myths about an electric vehicle where you shouldn't touch it. You could, there's, hazardous for electrocution. But when handled correctly and we put in all the safety standards, EVs are just like everything else that's around us in our world. It should become second nature. But the one thing that I am trying to put together, and it's in collaboration with Matt Shepanek, is a gentleman called Mike Cohen. He is the individual, one of my former colleagues. I'm going to go back a long time ago. I don't want to show my age here, but Mike Cohen is the individual who's responsible for writing all the EV standards for the last 5 years, where it's put it into perspective. He's now retired from Volkswagen of America, independent contractor. Mike and I are trying to set up where he would come down from to New Jersey. He lives in Boston, Massachusetts area. And, we've been tossing the idea about trying to put together, for everybody that's been involved in electric vehicles, putting together a training here at Camden County College or Camden County Technical School, hopefully before the summer, before the end of the school year, where we can invite all the automotive trainers, kind of do a second pilot of our curriculum and introduce it. And that's kind of my goal, is to have everybody have a more awareness of the electric vehicles and bring it into perspective there. So is there any questions on what we've done so far? Or, the other thing I definitely wanted to say, the words of advice here, working as an administrator now in the high school and trying to work at the high school level versus the college level when writing curriculum, a lot of learning curve I had to have. First thing I learned is everything has to be done by board approval. So it took, when we understood that we had to go ahead to do the project, it took another 30 days to get it on the board agenda, how to write that. Then after the board agenda, they had to get it approved. Who's going to work on it? Some of the things that, where problems were here is, how do you cross utilize from all the different manufacturers and try to put it into a standardized course? So I say, words of advice is do some research extensively into what's going on in the market, not just for now, but what's going to drive the industry in the next 5 to 10 years. The one thing is, all the different manufacturers have some slight differences on how they're driving EV technology. So the different, I'd say even just the plugins, to get, not to go in depth and try to be too technical today. When I first started doing the research and talking to different individuals, there's over 30 different types of plugs that were out there in the beginning. And in the United States, they were trying to bring it down to 1 or 2. That's still even a legislation of what type of plug to plug in an electric vehicle. So that still hasn't been 100% done, but it seems like the market leaders out there are driving that. And the second one was the last one was, how do we align our curriculum to teachable standards? And not having all the different varieties of batteries, chargers, even the safety equipment. One manufacturer will say this one set of gloves is good enough, and another manufacturer says, well, no, we need, this style glove with this type of inlay. Even with the batteries, some of the manufacturers out there, you have to dress in a full suit with headgear and all that you work on batteries, and other ones are saying that this is good enough. So that's the one thing that was kind of hard, is what do we put into the courses? How do we build them to industry standards? And the best thing I can say right now is ASE has done a great job of collaborating with all the different manufacturers. Their standards that they have now, I think, are I'd say the most in a collective, when you look at it, generalized, but they're also targeting the safety when it comes to working with an electric vehicle.
Okay.
So,
Thank you. I think what we're going to do is hold questions for the end. Is
Okay.
that right? Thanks, Wayne. So now I'm going to pass it off to Wayne Michello from Raritan Valley Community College. And just as a precursor, really, there are 3 community colleges in the state that really have very vibrant automotive technology programs that are in the process of introducing EV or bringing EV. And Raritan Valley is certainly one of the leaders, along with Camden and Brookdale. So we're very happy to have Camden and Brookdale working together. So Wayne, you want to take it away?
How's everybody doing this afternoon? Everybody hear me?
Yep.
Okay, good. Dr. McAlpin did a great job. I agree with it a lot of what he said. And over here at RVCC, we already have a program, AUTC 220, and it kind of fits into our 60 credit Associates of Applied Science in Automotive Technology here at RVCC. It contains 1 2-credit course in hybrid electric vehicles, and the planned expansion of the college's Workforce Training Center will more than double the footprint of the automotive technology program, and will support a substantial increase in hybrid electric instruction. In fact, we're taking delivery of some hybrid vehicles today, which is pretty exciting. A significant curriculum and program development in the area of hybrid electric vehicles will be required to meet the evolving needs of the industry and make effective use of the expanded automotive lab. So this is going to be the 2nd year of AUTC 220. We piloted it last year. PJ, you remember we had a training session on our hybrid electric trainer, the Lucas Nula training system, and we're going to use it again this year. So we already have something going, but this what's going on with the electric vehicles is just going to catapult the whole program. RVCC will develop 3 stackable courses aligned with 3 new ASE high voltage electrical safety standards for EV vehicles. That's XEV 1, 2, and 3. These courses will be designed to provide non-credit professional development opportunities for working automotive technicians, and will lead to the attainment of a micro-credential in hybrid electric vehicles. In addition to providing valuable training for incumbent workers, these courses will fulfill a credit requirement and a planned certificate of completion in hybrid/electric vehicles that will be available as an add-on to the existing AAS degree. Could you change the page, please? Next page. The creation of 3 new electric vehicle courses aligned with the AAC standards, gathering data and input to include in the courses, visiting electric vehicle locations. Credit and non-credit versions of the courses will be created to meet the needs of different partners and student populations. The courses are expected to run in summer 2025, of course, working with the expansion of our building, which is going on right now as we speak. Some of the challenges that we have right now is that, like Dr. McAlpin said, it is such a dynamic, whole new world for auto repair. There's so many things you have to be an automotive technician and a high tension linesman at the same time. That's the kind of current we're talking about, the kind of safety we're talking about. So ASC has not released the standards for XEV level 3 yet, which is still true today, as far as I know. And you know, for that exam or anything, any information to write the course. So it's difficult to determine the equipment and supplies necessary to ensure that the facility and courses meet the standards, because the standards really haven't even been written yet in some cases, and it's very dynamic. And like Dr. McAlpin said, there's so many protocols out there. There's so many different, you know, almost every manufacturer has a different standard that they want to go by. Plus, we've had some setbacks due to unexpected personal situations. I will say that I personally have been to BMW's training facility in Woodcliff Lake, New Jersey. The head instructor there was an author, one of the authors on the XEV 1 and 2. And they really rolled out the welcome mat for me. And I was able to really see, if you look on the next page, if you can go to the next page, please. That is one of the training bays at BMW. And they were very, very, very nice to me. They showed me all their safety protocols. That's a battery from a vehicle. I believe it's an X5 EV. They took the cover off. They showed me all kinds of things that they're working with, some of their training parameters, and it was a really good, kind of took the edge off a little bit, because I myself, I'm a little, you know, cautious about going forward with this, making sure everybody is safe, nobody gets hurt. I myself have been working with hybrid vehicles since 2006. I've taken batteries out and worked on the orange cables and things like that myself personally. But again, this is even more voltage, more current. And you know, it's a dynamic situation, and we're looking to, you know, make it the best as possible. It's going to be evolutionary. So the ancillary outcomes are going to be further networking within the industry, extensive knowledge gained regarding EV standards requirements for training facilities and other training programs. And the words of advice: take the time to do the research, speak to the industry partners, other training programs, research publications, and then industry standards as they develop. And, you know, we're all in this together. And I would actually like to work with Dr. McAlpin someday. Maybe we can collaborate.
That's fantastic. Thank you, Wayne. Okay, so we're going to segue from the curriculum development for students in automotive programs to EV exposure for high school students who are in engineering programs, automotive programs, and maybe even just general science programs, with the idea that if we expose the students to EV earlier, they're more likely to become an early adopter. Remember, these students are 16 years old. They're not that far away from their first vehicle or having influence on their parents' first vehicle. And even more importantly, the career opportunities that exist for them as engineers in the business side of EVs, as well as directly as automotive techs, which we're, you know, have a huge shortage of. So I'm going to first pass the baton to Mr. Steve Cohen from Applied Tech High School, who's doing a program with EV Rovers that he's going to tell us about.
Hi, everybody. I'm assuming you can all hear me. Yes, yes, yes. Excellent. So, it's been fascinating listening to the prior speakers and how the talk of foundational learning has come up. So our students are freshmen in high school, so anywhere between 14 and 15 years old. And the program that we're a technical high school, and our concentration is mechatronics or engineering technology. So we really are kind of primed to create this awareness for an audience that's sort of pre-selected for us, just based on interest in engineering. So there's quite a lot that goes into this awareness laboratory. We developed a curriculum that could really kind of be expanded past, say, 2 weeks to like a whole semester, depending on how much you really want to get into, electrical theory and Ohm's law and physics of everything from electricity to, drag and things like that. So we made some decisions early on that we didn't want to make this a construction project. We wanted to work with devices that were kind of ready to go out of the box. One of the reasons for that is that my students also do quite a lot of construction projects using some kit-based materials, and then also sort of solving engineering design challenges along the way. I can get back to that in terms of equipment, but they are educated on everything from how batteries work, the different chemistries of batteries, how batteries need to be handled, especially more volatile batteries like lithium-ion batteries and lithium polymer batteries. Also just about the concepts of electronic speed control, duty cycles, and brushed and brushless motors. We are giving them a kind of sampling or sampler of a systems-based learning. So we're talking about servos, we're talking about motors and pulse width modulation, square waves, how a controller communicates with a motor and things like that. And we are dealing with young minds, so we want to keep it kind of concise and I would say engaging in a fun way. So our first, we've run our first 2 cohorts, our first 2 run-throughs of this curriculum we did one in the fall, and we recently wrapped up our spring delivery of these topics. And I think the students were really engaged. Not only did we learn about how the vehicles operate, but we did operate them and used a sort of non-invasive logging system, if you will. We had our students design in 3D printing, 3D applications, design a holder for a cell phone that could run Firefox, which is a physics engine, and takes data from the IMU, the inertial measurement unit of the phone, to think about how much acceleration this little vehicle is experiencing. How can we make it closer to the experience of if there was real ham in the can, real bodies in the car? How would we tune down this vehicle to make it more road ready, more passenger safe? So that was quite successful. I would say that moving forward, I would want to try and kind of blend the projects a little bit better. And I'm a little leery of our equipment choice right now. Kids being kids, it does at a certain point, I try and tell them that there's no vehicle on vehicle crime, but you turn your back and the vehicles are climbing up their legs. So it's a little challenging in that regard. The durability of the equipment chosen, while we did provide backups, I found that it was maybe not up to the specs of something that would last in a classroom. Also found that the retention of the concepts really needs to be kind of brought, at least in terms of the physics concepts, Ohm's law and things like that. I think there needs to be further reinforcement. My class is a hands-on lab. I try not to really assign any take-home homework. Very little in the way of homework. And so if they're working on physics problems, that's not necessarily what this is about. But like I said, it is foundational, and they are young people. So here's thank you, Dr. Ricardo. So here's our students at work. They're being lectured on Ohm's law, as you can see on the screen, if you can, on the upper right. And then our other students are mounting their cell phones to get data. Moving forward, and also what I would say is our program covers a lot of this material with students building, for instance, their design challenge this year is to build a lunar terraforming robot, which is basically like a landscaping machine using a different platform. And that is still using many of the pieces of equipment and concepts, DC motors, electronic speed controllers, things like that, to make that vehicle. And I would say that as we move forward, it might be more engaging for the students to actually build a device, more like what's happening in the BCC go-kart lab. I think it gives them a little bit more stake in the process. And I think that they're doing very, very well, and we're really enjoying. I feel like this is my playoff music. Is that right, PJ? Am I getting played off? Right? Yeah. Okay. I'm sorry, I can't hear you, PJ.
Thank you, Steve. So I know Eric has to run back to class. He's got some students waiting,
Okay.
so he's going to give us his thing quickly. So thank you so much.
Sure,
We'll
sure,
take questions
sure.
at the
Yep.
end. So we're going to hand off now to one of our three high schools that are building an electric go-kart. And the first one up is going on at Teterboro High School, which is part of our Bergen County Technical School District. So Eric, you can take over.
Thank you very much. Hi, my name is Eric Buser. I'm one of the two automotive engineering design teachers over at Teterboro campus. So basically, I made some quick slides. We have two teams working right now. Each have 8 members. It's our junior class. So a bunch of 15 and 16-year-olds, 16 and 17-year-olds working on this. And we kind of split them up into internal groups as well. Frame design, the motor, the battery, the steering and braking, drivetrain, and wheels. That way they're all not sitting on top of each other trying to work out the same problems. So far, so good with that. They seem to be working well with one another. We have had some ordering issues with our materials, so we've kind of been working on paper and in Fusion 360 to kind of mock a lot of things up to start our designs and frames and such. So some of the challenges we've run into, just getting tax exempt quotes from some of these providers. We're trying to order the same parts for each group, so that way they can work on similar problems and solve the same issues together, work through it. I think that's gonna build a more cohesive program instead of having 2 separate designs at first, and it allows them to learn the material as well. Excuse me, they're making an announcement.
Please pardon the interruption. Will Reyes please report to the main office? Again, Louisa Reyes, please report to the main office. Thank you.
Sorry about that. So getting just tax exempt quotes, or there's 13 different manufacturers for things, so going to each one has been tough. I know they mentioned earlier, everything needs to be board approved. So trying to get all that together to get it board approved has been our biggest challenge so far. We finally got a bunch of the materials to start building the frame ordered today, which is really awesome. So hopefully when we get back from spring break in 2 weeks, we'll have the materials and we can actually start building some frames. We'd like to participate in the design challenge by June, but we'll see how that works. So we have some photos here. We have practiced conduit, so we've been practicing bending the conduit, measuring, cutting. On the left here, we have some students sketching out some frame designs and just kind of how everything's going to come together. And then we can go to the next slide. My kids really like Fusion 360, so they I had some photos. I'm not sure if they're here yet or not in the design of the students, actually, of their 3D modeling designs, but a lot of them have really gotten into it. So they took the measurements from McMaster-Carr, and then they went and used AutoCAD to scale the drawings properly, and then they put it into Fusion 360. So they're going to eventually hopefully have some awesome physical models of the entire go-kart, so we can use the finite element analysis in Fusion 360 to look at weak points and stress analysis. So they're getting some of that engineering principles of mechanics and materials, and as well as the electric EV side of it. That's what I got.
Thank you so much, Eric. And the one thing I will say is I've learned that myself, and feedback from the other schools is I allowed the community college students to get whatever they wanted, wherever they wanted it. And that was a big mistake. So we promise that the next version of the menu will be, 2 to 3 vendors total, as opposed to, I don't know if it was 13, but it certainly
Was
seemed
up
like
there.
13. So I apologize for that, and that's something we can rectify going forward. All right, thanks so much. Okay, so next up,
So much.
we have Professor Mark Balzarat from Bergen Community College, and he also teaches a dual enrollment course with our high school on campus, which is Applied Technology High School. And this is a senior engineering design course that he's building the electric go-kart with. So Mark, take over.
Okay, everyone can hear me too, I hope. The students have been working primarily on designing the frame and attaching the components. They've been using a Google Doc to document the work that they've done. They've done a number of pencil sketches. We're not working with any CAD applications at this point, but the pictures on the screen that you can see are the results of the past few weeks worth of work that the students have put in. They don't work on it on every session because the course is integrating this into the industrial design concepts that they're learning. But they've been very good at developing the MakerPipe go-kart frame, and they've made it really quite strong, in spite of the fact that the tubing itself, the EMT, electrical metallic tubing, is relatively weak in terms of its ability to flex, and because of its thin wall nature. But they've managed to come up with some very good solutions without any steering on my part as to where to go for a solution. They're doing very well with that. The next challenge is going to be getting those components mounted up, and I'm working with them to try to come up with a solution for the steering gear, particularly the axle, and where the wheel hubs are going to attach and how they're going to be done without having to weld anything. That's really the point here of this particular frame, is to not have any welded components, so that we can pass this design on to other schools that do not have either the equipment or the resources in their students to weld anything together. So I think that's an important consideration. We're also using the engineering design loop so that they understand the nature of concepts, testing, or concepts building, testing, and then making new iterations, which is really a fundamental part of industrial design anyway, is the importance of multiple iterations and working towards a solution for their problems. That's I think that's a pretty complete overview of what they're doing.
Mark, you just want to take us through the pictures super quick, like just tell us
Oh,
what's
yeah,
going
sure.
on in each one, and Stephanie, you can advance them.
Sure, absolutely. The students here in this picture are just assembling some of the MakerPipe components and choosing which ones are going to make the kind of joint geometry that is necessary for making the connections. In the next slide here, the students are working to make offsets in some of the tubing for the frame. We came up with the idea that having the frame be somewhat offset and then having more reinforcing points, while having a lower profile towards the front, would be beneficial to the overall geometry of the frame. And so they're doing some bending here. They're using a standard EMT bender that an electrician would use. And I was teaching them how to measure properly for where the bend radius is going to go, and they did it very successfully. And you can see in the next slide, they created a pair that are very, very close to each other. And so I think they're doing really well. We shouldn't be surprised when the students come up with really good solutions for their problems. And this is the overall group. There are some other students that have been working on this too. The class is a bit larger than what's shown in this picture, but they've all been assigned different areas, and then I rotate them around so that they all get exposure to the different components. And one group's not just focused on one area, but they get a good overview.
Thank
That's
you, Mark.
Oh,
That
you're
was
welcome.
terrific. Okay, so the last high school that we have working on the EV go-kart is a combination of two high schools. It's John Dwyer Technical Academy and Thomas Edison Career and Technical Academy. And we're very lucky to have a teacher and NJIT alum with us, Yuri Zekan. So Yuri, you want to take over?
Hey, how you doing, guys? My name is Yuri, and I'm teaching in Johnny Dwyer Technology Academy. I'm teaching engineering course, but we are working together for this EV Go part project with our automotive guys from another school. So students are supposed to go from one school to another school because we would like to combine engineering students together with mechanical students to share the experience and share the knowledge, share the ideas. So we already ordered all the parts, and it's in the process, and we are in public school. Everything is super long. So I just got the word yesterday that money is being transferred. So let's finger crossed we're gonna get it after the spring break, the physical pieces. The worst thing was to get all the quotes, all the vendors to be approved, and money being transferred to the companies. Meantime, I am engineering teacher and I'm also teaching robotics. So I applied this concept to my another class, which some of the students are interested in EV go-kart as well. So we built prototype of our EV go-kart
Oh,
on
wow.
robotics base, yes. And I'm not sure I'm gonna show you this, but it's running. We're changing pieces. It's running. We actually 3D printed the steering wheel and we 3D printed the seats. Now we are in the process of 3D printing a driver. So that's what it is, and everything is being remotely controlled. I'm just gonna show you so you can see that my steering works. As you can see that. And the
Wow.
steering wheel is turning and it's running under the motor.
Fantastic.
Yeah. So that's what we do while we wait for the bus, kind of. So yeah, hopefully after the spring break, seriously, yeah, that's our automotive teacher. So they were using him as a driver to pilot the kart, and that was really nice that we got the kart to see how it looks like. Kids were very happy to see it, and basically see the expectations, kind of. What kind of UFO is that supposed to be?
Yeah, exactly.
Yeah.
So I was very lucky to visit Thomas Edison and meet, what was that teacher's name, Yuri? He was quite a
Mr.
interesting
Yannick?
guy.
Steve.
Yes.
Mr. Yannick, Steve, yes.
Okay, so basically, what I thought was really neat was this kind of combination of the students who are the automotive students working directly, hopefully are going to work directly with the engineering students, because there's not a lot of trust between those two groups. If you know mechanics, they beat on the engineers all day long. They think, what comes out, they think they have to fix everything. So it's kind of nice if we could kind of change that those silos and get students who are going to be automotive technicians to work with engineers, so we can build a little respect between those two groups who kind of fight a lot. So I think that's a really wonderful, neat, wonderful part of the program that you're doing. So before we take questions, I just want to let everybody know, put everyone at ease who is building the go-kart. We're all at different areas of building. If we don't pull off the meeting where we all get together, we will definitely do it with the students before the project is completed. So we might not get to it in June if everyone isn't ready, but we will have 3 go-karts, and I don't want to use the word race because there might be somebody, you know, from the legal side here, but they will get together and have a rally at Bergen Community College either in June or maybe, you know, before it gets cold in the fall. So we will get students together, I promise that. But don't feel pressure, you know, to have to get done this year. Okay, so I'm done. Steph, you want to take over and go through the questions that have come up, or if anybody has any questions they want to ask directly?
So I don't see any questions in the chat. So if anyone does have any questions, go ahead and put it in there now. Otherwise, I'm going to move on. And
I did just add one. I had a question for
Sure.
Yuri. It's real, and I
Go ahead.
could reach out to Yuri later, but
No,
Yuri, I'm
please.
just looking at the image of your go-kart. Is that a new a hydraulic or pneumatic braking disc brake that I see?
So Steve, that's our go-kart. That's the pilot that we
okay.
built
Sorry,
last year.
sorry, of course.
Yeah,
Of course,
so
right.
it is pneumatic, and I can show you, I can get together with you and show you how it works. And Mark helped us a lot with that because it was very, very tough to get the fluid in there without any bubbles. So thanks to Mark, we had it where there was definitely a leak someplace, and when you go to press the brake, all
Yeah.
you're doing is compressing the air bubble and not getting brakes.
So it's hydraulic. It's hydraulic,
yeah.
not pneumatic. Got it. Okay. That's all I wanted to know. Thanks.
No problems. And I don't see any other questions in the chat. So I'm going to move on, and I'm actually stepping in for Catherine to say thank you to all of you for your hard work on these projects. Thank you to all of you who joined us this afternoon to hear about the progress. You know, it's exciting times to see high school students and college students. You know, last year they came together to build these these awareness projects, and then to be able to pilot them and to see the excitement. I love the idea of what you're doing with the mechanical engineering side students and bringing them together. Bridging those learning gaps is amazing. So we thank you all for that hard work. We're really excited to share all the work of all of our centers of workforce innovation. We're coming off of this week we had 4 center updates, but we do still have 2 more centers that'll be happening next week. So on Monday, we have the Center for Data and Computer Science. And on Thursday, we have the Center for Manufacturing and Supply Chain Management. If you scan the QR code, you can register for that. We're also very pleased to give you the dates. Last year, we had our inaugural Pathway Summit. And this year, we are bringing it back again in June. So look for information on that. We just have to save the date out. You should start getting some information. We look forward to seeing you there. And then finally, we always love for you folks to talk about the work that you're doing on the projects related to Pathways. These are our channels on social media. Please do talk about the work that you're doing, talk about the centers, talk about, you know, the great work that your students are doing in these projects. So thanks again for joining us, and we look forward to seeing you soon. Enjoy your Friday afternoon.